Math 2 Enhanced. This is Unit B, Lesson 1's notes on building polynomials given the roots. So from Unit 1, we know that a quadratic function could have the roots x equals 2 and negative 4. So let's put a dot at 2 and negative 4. And we were supposed to find the factored form, standard form, and vertex form and graph it. So I'm going to work with the factored form just real quick because I know if my roots were 2 and negative 4, that my factors must have been x minus 2, the opposite, and x plus 4. So when I solve each of those, I get negative 4 and 2. I also know that my vertex is halfway in between my x-intercepts. So since they're 6 units apart, 3 units away from, or to the right of negative 4, and 3 units to the left of 2 would put me at negative 1. So I know for my vertex, I know my x-coordinate's negative 1. So let's go find my y-coordinate. I'm going to plug it into my factored form. So y equals negative 1, that's what my x is, minus 2 times negative 1 plus 4. So I get, what is this, negative 3 times positive 3, or negative 9. So my vertex is negative 1, negative 9, and I can put a dot down here at negative 9. And I could go 1, 1 to the left, 1, 1 to the right, 2, what is this, 4, and 2, 4. And I could softly draw in my graph. Remembering that it's more of a U and less of a V. So now standard form, I'm going to multiply out my factored form to get my standard form. So when I multiply this out, I get x squared for my first term, and then a negative 2x and a positive 4x, so that's going to give me a 2x when I combine them, and a negative 8. If you need to do your box or foil out to the side, please do that. And then the vertex form. Well, I know my vertex form is y equals my a, which in this case was 1, times x minus h. So when I plug in my negative 1, it looks like x plus 1, because x minus a negative 1 would be x plus 1, and then minus 9. So let's move on and take a look at the first example for our polynomials. This says, given the following roots, and you'll notice there's 3 there, of a polynomial function, create a function that would have those given roots. Please multiply the factors and write it in standard form. So looking at these roots, I can figure out my factors. So I'm going to use p of x for polynomial, but you could use f of x here. You could really use y. So I'm noticing the x equals 0. Whenever I see an x equals 0, that means that I'm going to have a single x as a factor, because I would set that x equal to 0. That's how I get a 0. So I'm always going to put it in the front. So I'm always going to put it first when I have that situation. So I'm going to write my x first. And then I have an x equals 3. So I know my factor that goes with that would be x minus 3. And I have an x equals negative 4. So I know my factor that would give me that root would be x plus 4. So now my job is to multiply this out. You can really multiply it out in any order. Multiplication is commutative. I like to do my FOIL or box method first, and then I distribute my x. So if you need to FOIL or box, do that out to the side. Pause this video and do it out to the side, and then check your answer. You should get x squared plus x minus 12. So I'm not done yet. I'm now going to distribute that single x factor that I had to all 3 terms. So my final answer for p of x is x cubed plus x squared minus 12x. And since this has an x cubed in front, that's why it's in this unit. It's no longer quadratic. Actually, when it has an exponent of 3, this is an example of a cubic function. We say that the degree is 3 because that's my highest exponent. So this is a cubic polynomial and its degree is 3. So out to the side, I'm going to do a rough sketch with you, although really graphing is our 4th lesson in this unit. So I don't really expect you to be able to graph it. However, let's think about what we know of these roots. So I know x equals 0. I know x equals -4. I know x equals 3. So now this is the thing, one of the things we're going to learn when we do graphing is that when I have a cubic 3rd degree polynomial that has a leading coefficient that's positive, my graph is going to fall from the right side. So it's going to fall down through 3. Somewhere it's going to come back up and go through its next root. It's going to come back up. Somewhere up here it's going to fall down and come back through the 4. And this, why did I stop at the top, start at the top right, and why did I draw, and why am I ending going down on the left? That's because this is a 3rd degree cubic polynomial, and also because my leading coefficient, that's my x cubed, is positive. If it was negative, I'd be going the reverse direction. But again, we're going to learn that in Unit 4, or Lesson 4. So let's take a look at the next one. It's got something interesting in it. It has both multiplicity and a fraction. So what do I do when I have this situation? So I'm going to start out the same way. My p of x is equal to, and I'm going to write my factors. So x equals 1/2 gives me x minus 1/2. Now multiplicity of 2. This means that this root is a root twice. So for example, we really have x equals 3 and x equals 3. This is a root twice. That's why it has a multiplicity of 2. So then I'm going to write it twice. I'm going to write an x minus 3 and another x minus 3 since it had a multiplicity of 2. So let me first talk about how I want to handle that 1/2. X minus 1/2 isn't in itself wrong. It's fine, but it's difficult to start multiplying with fractions. And so it's much better to clear the denominator there. Well, how do we clear the denominator? Imagine this. So I'm thinking in my head, this is x minus 1/2 equal to 0. If I wanted to clear the denominator, I'd multiply both sides by 2. And I get 2x, and when I multiply the 1/2 by it, the 2's would cancel, minus 1. When I multiply the 0 by 2, I get 0. So x minus 1/2 and 2x minus 1 are equivalent. And so I'm going to write them. So I'm going to basically be popping my 2 up in front. And instead, I'm going to write my polynomial as 2x minus 1 instead of x minus 1/2, because they're the same, times x minus 3 times x minus 3. And now this is much easier to multiply. So for me, you can multiply these in any order. You basically have to pick 2 and get to work. If I was looking at this, I would probably multiply these 2 together first. It just kind of looks easy to think in my head. If you want to FOIL or do the box method out to the side, please do that. So I'm going to get an x squared and a minus 3x and a minus 3x, so minus 6x, and a minus 3 times a minus 3 is going to give me a plus 9. So now I have a trinomial. I have a trinomial because it has 3 terms, trinomial. Then I'm going to multiply by this binomial. So I like to use the box method. Can you use FOIL? Technically, yes. But once I am using something that has 3 terms in it, I go ahead and move to the box method myself. So I would set up my box. My box needs to have 3 spots on one side and 2 on the other. So I have room to put my 3 terms and then my 2 terms of my binomial. Could you have done the x squared minus 6x plus 9 down the side? For sure. So now I'm going to start multiplying. So this is 2x times x squared, so it's really like 1x squared. So 2 is my coefficient, and this is an x to the first. X to the first times x squared is going to give me an x to the third. When you multiply like bases, we add the exponents, so I get an x cubed there. So now I have a negative 6 times 2, or negative 12x, and this is an x to the first times an x to the first, so I'm going to get an x squared. And 2x times 9 is 18x. Now I have negative 1 times x squared, or negative x squared. Negative times a negative is a positive 6x. And finally, a negative times 9 gives me a negative 9. So notice I do have some like terms on my diagonal. So as I write my answer, I'm going to clean those up. So my leading term is 2x cubed. And then I have what? Negative 13x squared. And then 6x and 18x is that 24x minus 9. So this also has a degree of 3. My highest exponent is a 3. That means it's a cubic function. Just like quadratic functions have an x squared, they're degree 2, or linear functions have an x to the first, a degree 1. Cubic functions have a degree of 3. And I'm done. So those of you that are in the classroom at this time, I would display the graph using Desmos. So if you're at home copying this down, feel free at any time to type in either the standard form or the factored form to take a look at what this would look like as a graph. So let's go on to the next page of our notes. So now this is roots with a radical. Oh no, what am I going to do with that? So let's check this out. So I'm going to start again by writing my polynomial, and I get a x minus 2. Now what do I do when it has a square root? So off to the side, so I'm going to go aside, off to the side, I'm going to set this up, x equals 4 plus or minus the square root of 3, and I'm going to do something I like to call the reverse complete the square. In other words, I want to work backwards and find out what trinomial gave me 4 plus or minus the square root of 3 as an answer when I solved it. So I'm going to be doing what we did in the last unit backwards. So my first step is to move the constant term. So my constant term is the 4. So since it's positive, I'm going to subtract 4 from both sides. So on the left side, I get x minus 4. And on the right side, I get plus or minus the square root of 3. Now that I've got the plus or minus square root of 3 isolated, I am going to square both sides to get rid of my square root. So on the left side, I need to square the entire binomial. And on the right side, when I draw this, I tend to draw through the plus minus because the plus minus is going to go away when I square it. So you don't want it anymore. So either cross it out or draw through it, but don't let it confuse you. It's gone. Now that I'm squaring both sides, I'm no longer going to have the plus minus. So on the right side, be careful. You don't say that this is like x squared minus 16 or something like that. It's not. Remember, I don't normally do this in my work. You won't see this, but this is really, you have to write it twice. It's x minus 4 times x minus 4. And then the square root of 3 squared would be positive 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So on the left side, I've got x squared minus 8x plus 16 equals 3. So my very final point is to set equal to 0. So I'm going to subtract 3 over and subtract 3 over. I end up with x squared minus 8. Oh, I'm sorry. If you go up one line, can you put an x behind the 8? I'm so sorry. I was writing fast, not paying attention. When I multiply x minus 4 twice, I get x squared minus 8x plus 16. So then this is x squared minus 8x plus 13 equals 0. So this trinomial, when I solve it, gives me this for an answer. Most of you may not have used complete the square to solve it. You might have preferred using quadratic formula. That's fine. You still would have got 4 plus or minus the square root of 3. So now I put this guy in as one of my factors. This is my x squared minus 8x plus 13. So now this problem is multiplication. If I want to write this in standard form, I need to multiply it out. So I need to put my trinomial on one side. I'm going to put it across the top, x squared minus 8x and 13, and my binomial down the side. So again, when I'm multiplying, x times x squared gives me x cubed, x times minus 8x gives me minus 8x squared, and x times 13 gives me 13x. And across the bottom, I have negative 2x squared plus 16x. And what is this? Minus 26. And so I notice I have x squared terms and x terms to combine. So my final answer for this one is going to be x cubed minus 10x squared plus, what is this? 29x minus 26. If you were in the classroom, I would graph this. You can either graph the standard form or you can come back up here and graph the factored form so you can see what this looks like. Graphing is our 4th lesson, but I'd like to show you guys the graphs so you can see what these polynomials are looking like. Again, this one has a degree of 3 because my highest exponent is 3, means that it's cubic function. So let's take a look at the next problem. The next problem has a fraction and an I. So getting started, I'm going to start with my f of x or p of x or g of x or really anything you wanted to write there. I'll use f of x this time. This is x minus 1/2. I'm not going to leave it that way, but I am going to start that way. And I'm going to handle a complex number with a square root much the same way as I did a square root. So off to the side, I'm going to reverse complete the square. So x equals 2 plus or minus 2i rad 3. And I'm going to begin my steps that I had wrote above in my notes. So my first step is to move the constant. The constant is this 2 that's out in front of the plus minus. So I'm going to do the opposite and subtract 2 from both sides. Now the 2i is the coefficient on the rad 3. They are not a constant. Do not move those. So now I've got it isolated to where I have just the plus minus 2i rad 3 term. This is where I'm going to square both sides. I'm going to draw through this and I'm going to square both sides. And on the left side, don't forget to write it twice. And if you FOIL or box, still do that out to the side. Pause the video and then come back. You should get x squared minus 4x plus 4 on the left. Now on the right, I basically have to square each term. There's no plus minus here, so this isn't boiling or anything. I just have to square each term. So 2 squared is 4. I squared is negative 1. Remember, I squared equals negative 1. So I times I would give me a negative 1. And square root of 3 times the square root of 3 is the square root of 9. If you didn't understand that up above, I get the square root of 9. I can multiply those because they are like terms, and that would give me a 3. So I have x squared minus 4x plus 4 on the left, and I have negative 12 on the right. So my last step is to get it to set equal to 0. So I'm going to add 12 to both sides, and I get x squared minus 4x plus 16 equals 0. So I'm going to put this back into my problem. So another one of my factors is x squared minus 4x plus 16. So now this is where on my fractional one, I'm going to change it. I'm going to multiply the whole thing by 2 so that I can rewrite it as 2x minus 1. Like that, much better to multiply with, no fractions. And x squared minus 4x plus 16. Just a side note, this is my linear factor. Linear because it's got an x to the first power. It's really a line. This is my quadratic factor. We've just done a quadratic unit. Quadratic because it has an exponent of 2. And a linear term, or a linear factor times a quadratic factor will multiply together to give me an x cubed factor, or x cubed polynomial, which is cubic. So let's do the multiplication. Again, you could put the trinomial either down the side or across the top. I tend to like them across the top. And then I'm going to do my 2x minus 1 and my x squared minus 4x plus 16. And 2x times x squared, so that would give me an x cubed because I do my x to the first times x squared. What is this? Minus 8x squared. 2x times 16 is 32x. Negative 1 times x squared is negative x squared. Negative 1 times 4x is 4x, and negative 1 times 16 is negative 16. I notice again my like terms. So it looks like I'm going to get f of x is equal to 2x cubed minus 9x squared. What is this? Plus 36x minus 16. And again, I have a third degree cubic function for my answer for my polynomial. Thank you so much, and see you in class.